A well is drilled in stages. This means that we start drilling with a large diameter bit before stopping at a predetermined depth and putting in new casing. This casing must then be cemented in place to support the newly drilled section of the hole. To drill the next section of the well, a smaller drill bit must be used so that it can pass through the casing which has just been put in place. The diameter of each hole section and the depth to which it is drilled can vary quite a lot depending on location, geology, and of course the final depth that the well will be drilled to. As you have already seen, a well is usually drilled in 4 or 5 stages, each being drilled at a diameter smaller than the one before it. A typical casing scheme for a well with 4 casings could look like this. First, a 36-inch diameter hole is drilled and the 30-inch casing is placed in the well. Next, a 26-inch hole is drilled and 20-inch casing is run. Then a 17.5-inch hole is drilled and 13 3/8-inch casing run. Finally, a 12.25-inch hole is drilled and 9 5/8-inch casing run. All of these are cemented in place. The next hole section, usually across the reservoir, is typically 8.5-inch. A 7-inch casing is run in the 8.5-inch hole section. It may be run back to surface and cemented in the same way as the other casing strings, or suspended from the bottom of the 9 5/8-inch casing, in which case it is known as a liner. The liner may or may not be cemented in place. The use of a liner saves time and money, as much less casing cement is required. We will now demonstrate how a section of casing is cemented in place, having already set the 30-inch conductor casing in position. Drilling recommences, and the bit is rotated and pushed down by the weight of the drill string and its components. At the required depth, drilling stops, and drilling fluid is pumped through to clean the cuttings from the hole. The drill string is withdrawn, and casing is lowered to the bottom of the hole. A special rubber plug is inserted via a cement head into the top of the casing. Cement is pumped after it and down the casing until the correct volume of cement has been pumped. Then a second plug is inserted. This is then pumped until the first or bottom plug bumps against the bottom of the casing. Pressure builds up until a diaphragm fitted in the first plug bursts, allowing cement to flow into and up the annular space outside the casing. Cement flows until the second, or top, plug hits the body of the bottom plug. As this plug is solid and doesn't contain a diaphragm, pressure builds. This pressure rise is used as an indication to stop the cementing pump. When drilling restarts, a smaller bit is used. The plugs are drilled through, creating the next hole section. Once the drilling of this section is finished, smaller casing will be run into it, and the whole cementing process repeated. Casing is made up in sections, or joints, to form longer lengths called casing strings. Joints are usually about 40 feet long, connected together and lowered into the hole until the designated depth for the casing has been reached. Each connecting joint has to be tightened up to a specified torque, or force, with thread lubricating compound being used on the two ends to help ensure a tight seal. Every so often, centralizers are attached to the casing as it is being run into the well. Centralizers are bow-shaped strips of spring steel that help keep the casing centralized within the wellbore. The well is conditioned prior to cementing by circulating clean drilling fluid down the casing and up the annulus. This is designed to prevent cement being contaminated when it is placed in the hole. When the 20-inch casing has been set and cemented in place, the blowout preventers, or BOPs, will be put in place. As the name implies, BOPs protect the well by preventing blowouts and controlling unexpected conditions that may affect the stability of the well. Prior to the installation of BOPs, any formation fluids released would be diverted away from the rig. We will learn more about BOPs in modules 3 and 4. As drilling continues, the mud weight is altered to allow for changes in the formation and pressures that may be encountered. If formation fluids enter the wellbore, the BOP would be closed to stop the flow and prevent the fluids from reaching the surface and allow us to regain control. Cementing is a key feature in the life cycle of a well, from cementing the casing through to remedial cementing, and finally when the well is to be plugged and abandoned. The cement that has been placed between the casing and the wellbore has to last the life of the well, and the integrity of the well is dependent on the quality of the cement jobs. Each section of the well that is cemented will have its own special recipe. This is referred to as the cement slurry. The recipe for a cement slurry has to ensure the ideal bond between casing and wellbore. Various additives go into the slurry to keep it compatible with the formation, stop it setting too quickly or too slowly in some cases, and ensure it is easily pumped. Before the cement slurry is mixed and pumped, it is tested in a laboratory to be certain that it is exactly right. Integrity of the cement job is lowered into the casing to verify the cement is where it should be and is completely bonded to the casing and wellbore. When approximately 30 feet of new hole section has been drilled, the first job to be carried out is a formation integrity test, or leak-off test. This involves gradually pumping a small amount of drilling fluid into the well until it reaches a designated pressure. Many factors affecting well control rely on this test, but it is also used to evaluate the strength of the cement bond to ensure there are no possible leak paths to formations higher up in the well, and to confirm the new hole section is strong enough for the maximum mud weight required to drill the next section.